Stuff it. I can't be bothered waiting for the countdown. Okay. Two things are true. I'm late for my own live stream, and what was the second? I'm totally disorganized. That's it. So, in other words, it's a normal Sunday. Hang on. I think the audio level might be a bit on the high side. I'm going to crank it down a little bit. Hopefully that looks a little bit better. Oh, so I acknowledge the traditional owners of this land. I pay my respects to the elders past and present, and to Aboriginal elders and peoples from other communities who may be taking part in this live stream today. So, Peter says, clearly I live close to a train station. Yes, not, well, close enough that it doesn't take long to drive there and back, far enough and over enough hills that walking is a little bit of exercise and takes a while. So yes, that is why I had a last minute request to please drive me to the train station. All right, now deep breaths. Gerald, Mike, Johnny, Peter, Michael, Chip. I'm going back up the list. Lots of people here. Sion's here. Yeah, so a late start. You're right, Sion. Aaron. Okay. Aaron said, check your Discord direct messages. I messaged you a couple of weeks ago related to this project. Not sure if my messages are getting through. All right, so I need to open Discord for the first time in a while. My notifications are going to be fun. Dodgy says, got coffee. My wife is good enough to bring me a cup as I set up for the live stream. Normally when you see me on a Sunday morning, I've had 1 cup of coffee. Today I've had 2. I think it's been necessary. Morning, Gil. All right. Still waiting for Discord to start. Not that you care about that. You don't need that. I was hoping to have a lot more preparation done today. I had an idea about something, and I think we can still pull it off. Something that I did on my laptop, and I don't have it here on my desktop, which I'm currently using for streaming. But my laptop is back there, and I think we can probably jerry rig something, get it working. So what I was wanting to talk about today, well, what I was wanting to show you, all my live streaming setup, it was a total mess. That's the other thing this morning when I walked in. Because I've been experimenting with the Atom Mini, and I also, when I did that impromptu live stream last week, I did that from my Linux machine. So I installed OBS on Linux, and I plugged the capture stuff into that, which meant that all of my HDMI cables were plugged into the wrong place. So it was a mess this morning. And I don't actually have my scene changer. So let's see, if we go to overhead, that one, that is the one I want. Oh, hang on, where is, yeah, my OBS setup is all stuffed. So you can see the overhead camera. Hang on, let me try this one. How's that? Yes, that's better. So now we have the front camera and the overhead camera. And here we have UT61E Wi-Fi interfaces. But there is a little mess up. So this is something that I talked about. Oh, Sion says Atom is unplugged. That's not good. I'm going to, the short answer is it's going to be plugged back in again, but I didn't have time to get it into a neat state before beginning the live stream this morning. I need to do that another time that's not directly before a live stream, so that I've got time to get everything sorted out. This morning when I walked in, it was a bit of a panic of what's the most predictable thing I can do, which is just plug everything back in the way I had it originally and not worry about it, rather than experimenting with a new setup with different feeds into the, using this as a capture device and everything. So I did use this. I had this when I did the last live stream, the impromptu one. I did it using this, but it was this capturing the cameras into the different inputs, and then USB into OBS on my Ubuntu machine, and that seemed to work pretty well. So I'm going to get it set up, just not yet. Now, okay, so as I explained on the other live stream, there is a bit of a stuff up. Let's go to the microscope and I'll show you what I've had to do. Look at that. There is a bodge wire. So the problem, hang on, can we get better focus than that? That looks okay. So the problem is, what we are doing is using USB through the serial connection to report back to the host computer, but to acquire data from the multimeter, we need to set up a software serial interface. And for the original messing around, when we were playing around with the stuff on the breadboard, we had the Lowland 32 Lite on there. What I was doing was using one of the second hardware, I was using the second hardware serial port on the ESP32, because the ESP32 has multiple UARTs. And so I was using GPIO 16 as the receive pin on ESP32, and that was working fine. So all of the stuff we've been doing previously with this multimeter hack project, we've been acquiring data on GPIO 16. And I had a total brain fart moment. And when I was laying out, right, I'm just going to launch Eagle so we can have a look. When I was laying out the PCB, so laying out this one, this little PCB, for some reason, it didn't even cross my mind that we were changing from an ESP32 to an ESP8266, because this is running a D1 Mini on it. And so I just left it on GPIO 16 thinking, oh, that'll be no problem. I can just run software serial. We only need, what is it, 19,200 bits a second, I think, is the baud rate for this interface. And then after I assembled the boards and I just changed the software, compiled it for the ESP8266, I discovered that GPIO 16 is one pin in particular that you cannot use for software serial on the 8266. There is a limitation on that particular pin and some other pins that prevent you from using it for that purpose. So I ended up having to switch to a different pin, and that is what this little bodge wire is for. You can see that the track comes down here, and originally, well, the original track comes across here and it joins onto this pin, so that's GPIO 16. And what I've done is cut the track. You can just barely see there's a cut just there, and then use some wire wrap wire to extend the track, bring it down and connect it to this one. So the result is that instead of being on Instead of being on D0, it's now on D5. So instead of GPIO 16, I can't even remember what the D1 Mini pin translates to. Yeah. Linux is a mostly, almost, not quite clone of Unix. Yeah, well, that depends on what your definition of Unix is. I know a lot of people that say Linux is Unix now. So are we talking about SCO Unix and which release, etc.? Oh yeah, and SCO can die in a fire. Although I think they already have. What ended up happening with that? So there was the lawsuit with SCO. Anyway, let's not chase that particular rabbit. I don't want to talk about 20-year-old legal arguments, or 15-year-old legal arguments, and copyright lawsuits and things. That's not so much fun. Yes. Yes. SCO is an evil twin. It is. Oh, Michael says it's recently fired up again. SCO is back? Do we need to smack it on the head again? All right. It's happening already. My brain is off chasing squirrels because of something that came up in the chat. All right. All right. Where are we now? Oh, actually, this is definitely a squirrel. It's not related to what is on the screen right now, but it's worth bringing up. And I've kind of mentioned this before. The question of when I do these live streams. So I was actually quite shocked when I did the impromptu live stream. And when was it? I think it was Thursday, or was it Friday night, a week ago. And I got on a live stream. What time was it? It was in the evening. It was like 9 o'clock at night, 8 o'clock at night. And within a few minutes, there were 73 people on the live stream, which is more than are on the live stream right now at the regular time when there are people have notifications of it, and I usually tweet about it and put it on Facebook and things like that. And so what I thought was, when I did that impromptu live stream, I might get like 3 people turning up to it just because they got the notifications. And wasn't it a Friday night? Yeah, I think it was a Friday night, but it was like late on a Friday night. And so my expectation was that I would just hit go live, and I would just say that I couldn't do a live stream that week, and about 3 people would get the notifications and see. And I had more people on that for that live stream with no warning than come along on a Sunday morning. So Johnny says, yes, this is in the middle of the night for us. So anyway, what I've been thinking about is maybe I should change the live stream time. Maybe I should be doing it Sunday evening instead of Sunday morning, which might be better for other parts of the world. And yeah, it might be okay for people in Australia too. I don't know. So I've been thinking about that. Maybe I should switch to a Sunday evening live stream, or maybe I should do a Sunday evening live stream as well. My life would become live streaming. What am I doing? All right, so hang on. What happened to Eagle? I thought I was opening Eagle. Where is it? It has opened. It just took a really long time. All right, so projects. And let's switch to desktop view. And what am I looking for? Oh, that's right, UT61E WiFi hardware. So what I've done is, all right, so to summarize my thinking about what to do with this project and the fact that the pin is now incorrect. I had, how many was it? There's 6, oh, there's the packet here. Fell apart. This is the packet. I had 20 of the PCBs made for this, just because they're small and I was piggybacking it onto another order. So, this whole thing is kind of it's just a messing around sort of project. It's nothing serious. So I don't expect that I'm ever going to make more than the 20 boards that I've had fabricated. And so what I'm doing, this is my plan basically. So what you can see here is this design is version 1.1 of this PCB. I've already revised it. So what I've done is moved this data pin from D0, GPIO 16, and I've brought it down here to match the patch that is on that particular module. And it comes into D5, which is GPIO 14. And I have changed the firmware. So the firmware that's on GitHub now points to this I/O pin, and the design files now have the connection to that I/O pin. Now the reason for doing that and pushing it is that if someone else comes along and finds this repo, I want them to see something that works, not something that doesn't work. And so even though I haven't produced these, and I may never produce the version 1.1 PCBs, because there might be 3 people that will be interested in getting this board. So what I've done, I'm knocking stuff over. So what I've done is assembled 6 plus 1 for myself. This is it. So this is the roster of these little multimeter adapters, and then I've got a few spare PCBs that haven't been assembled. So what my plan is, and I've patched all of these, so each one of these has the little bodge wire on it. I've also ordered some clear heat shrink so that I can put heat shrink around it, and there was an offer. Also, please remind me, was it James who offered to design a 3D printable case for this? I have a feeling it was James, but if it was, please speak up, please confirm. So what I'm going to do is heat shrink these and clear heat shrink so that you can still see the LED and see the squirrel, because that's the most important feature of this thing, and make these available. In fact, these are available right now. Oh, also, sorry, group UT61E WiFi. So the URL, this is kind of a miracle. The URL on the PCBs works. It takes you to a real live web page, which is very unexpected for something that I've done. And so there is now a web page where you can go along. I've put 6 in stock. I just put $20 on them as a price because I don't know why. It just seemed not too unreasonable. Yes, I know that this whole thing is 2 resistors, a transistor, capacitor, and an LED, plus a connector and a PCB, plus a D1 mini. So the idea is that this is all inclusive. What you get for your 20 bucks is the entire thing, fully assembled, with the D1 mini on it, and yeah, ready for firmware. In fact, what I've done is I've already loaded the firmware on all of these, but you'll need to reload it in order to match your Wi-Fi credentials and all that sort of thing. No, sorry, Peter. I have broken your expectations. Yeah, anyway, so the whole pricing thing here. This little thing, $20 seems ridiculously overpriced to me because of what there is in it. The actual bill of materials cost, even including the D1 mini, I think the bill of materials cost on this comes to like $7, $8. It's in that region anyway. And $20 seems like it seems like a lot for something that is so simple, but it's kind of a specialist thing, and I sat here for a couple of hours and assembled a few of them, so I got to take that into account. And also I'm going to supply a USB cable with these as well, so they'll come in a USB cable in proper packaging and everything. So anyway, I'm being very apologetic about the price here. That's just the way it is. I never feel like I can price things properly. I always feel like I'm overcharging, and yet it's still not even worth my time to be making them at that price. So Where are we? Oh, okay, links, design file. So if you go to the link to GitHub, hang on, I'm going to, yeah, it's kind of circular. So we've got the GitHub link here. I'm going to drop this into the chat. Yes, Cabletti, it should be priced on value, not just cost of goods sold. You are absolutely right. Yeah. Anyway, this is the repo, and this one has the updated design files, and I've made a note on here saying that the pin has been changed from GPIO 16 to GPIO 14, and the photos are of the V1.0 PCB. And and there's a link there to the page where you can actually buy one if you want to. Now in firmware, what we have here are 3 different chunks of firmware. There is the serial reflector, which is what we were using originally just to make a connection to the multimeter and a connection to the host and just bounce the data through it. It doesn't do anything more than that. And I think, let's see, what isn't it? Yeah, it just opens a second serial port and it just reflects around. So whatever comes in from the multimeter goes out to the host. I left that in there just because it's useful to do some testing, to see if you've got a valid connection to your multimeter. This only works on the Lowland, on the ESP32 though. It doesn't work on these little boards. So then there are 2 different versions. There is the D1 mini version of the firmware and the Lowland 32 version. So the Lowland 32 version is what you would use if you're breadboarding it using a Lowland Lite or, you know, whatever you want to use. And it's got a config example. Did I reveal anything bad in here? Whew, no I didn't. Okay, so it's got a config.h-example. So what you need to do is take that and rename it to just config.h, put in your Wi-Fi details, put in your MQTT details, username and password if you have it, and then you can compile it for the Lowland 32. And then there is the D1 mini version. So this is the version that is optimized, wrong word. It's basically, this is the version that runs on these little devices. And it had, it still says ESP32 version. I've got to fix that. So it uses the WS2812. It's very hard for you to read, isn't it? I should zoom this way in. So it uses the WS2812 to display status. And what it does now is, as it's booting up, it goes through different colors on the LED to show you its progress of connecting to Wi-Fi, connecting to MQTT, and ready to go. And then once it's receiving data from the multimeter, the LED flickers green each time it gets a packet of data. So twice a second, you get a green flash, and then you know that you are getting data from your multimeter. Anyway, I think we'll connect this up in a minute and see what it does. Maybe hook a signal generator up to the multimeter input so we're getting some data and see what comes back. Include Wi-Fi. Yeah, there's still some stuff here that needs cleaning up, because this is what I did was took the Lowland 32 version and duplicated it, and then I just modified it to make it work on the ESP8266. I'm going to go through all this code. Oh, you can see the stuff here where it's setting the colors on the LED as it starts up, and it doesn't do any decoding. So there's lots of work to do from the software side, and maybe we'll have a look at that today. That's something that I was going to show you on the. That's what I was referring to earlier about the thing on the laptop. I've got stuff on the laptop that does packet decoding for the data from this. It's not my work; it's someone else's work, but it works, which is cool. So now we have a page where if you really, really wanted to, you could go and buy one of these things for the few people that have a UT61E multimeter, and then you can grab the example code and load it up. Now I'm going to switch away. What I'm going to do, green flash. Did someone say triethyl aluminium? Or if you're American, should it be triethyl aluminum? I don't know. What was I going to do? That's right. I'm going to... Do I need to open the IDE? I don't think I do. All right, let's get a connection onto this. And overhead, that. All right, let's get one of these hooked up and get some data and see what we can do with it. Doesn't matter which one. They should, at the moment, these are all loaded with firmware that links to my Wi-Fi and my MQTT broker. In fact, I think I'm going to change some settings and maybe reflash it. So now that you can't see my screen, I'm going to edit the config file of the for the Wi-Fi and the broker, etc. Now, what can we do? I need the signal generator. Okay, I'm gonna, it's normally mounted up above the bench, but I'm gonna pull it out so that we can get it in a place that it can be seen. I think we're gonna need a little bit more field of view up here, so let's zoom out. And then, what else do I need? Ideally another multimeter, because I want to be able to see what's on the screen. Where is my... I've got another UT61E over here, I think. The one that normally lives... Yes. The one that normally lives in my backpack and goes everywhere with me. It's still got the wires hanging out of it from the early experiments that we were doing. All right. I think this still works. Like it slides over the top of those wires. Is it going to fit? All right, so this is the optical interface that pulls the data out of the back of the multimeter. And data is going to be floating around in the air, coming off the end of that blue wire. Is it blue? No, I think the blue wire is the ground connection, the yellow wire. There will be data trying to escape from that pin. And then it's available on here. And then we plug that in there. I'll turn it over this way. It's kind of a weird thing because normally you would look at it like this and have the D1 Mini on top. But the way I designed it, it's kind of meant to be like this, so it sits upside down. You can see the squirrel and stuff on there. That's where the LED is exposed. Now I need... What else do I need? I'm going to need power for the signal gen because I've pulled it off the bench. I'm going to need to plug it into... What will I plug it into? I'll plug it into a lab supply because it needs 5 volts at a surprisingly large number of amps. And plug that in there. What do I want? 5 volts, 2 amps, on and go. Yes. Now, channel 1. Need some signal. Aha. Somebody set up us the bomb. We have signal. So we should have, I don't even, what is this set to? It's a very high frequency. Well, not very high. It's set to, no, it's actually not very high at all. This is set to what we were doing when we were experimenting a little while ago with the, with cleaning up the signal. So yeah, it's set to 100 Hertz. We're only going to get 2 samples a second coming off the multimeter. And we also need USB. I've got a heap of USB cables hanging here, but I need one. What about this one? Yes, this one will do nicely. So if I plug USB in here, now we get the LED coming on as it starts to boot. And oh, you can just see it, I think, on the camera. If I cover it, you see the green flash. If I get the angle right, there. You're only seeing it intermittently, which is weird, and I think that's just because of the frame rate of the camera. It's when the frame rate of the camera happens to coincide with the timing of the LED flashing. But that LED is flashing green, which shows that it's getting data from the multimeter. We're in voltage mode, turn on the output, and we now have the multimeter. Oh, it's averaging. Because the multimeter sample rate is very low, I wonder how low we can go with this. Let's see. What can we do? Start frequency, stop frequency. Anyway, let's look at that in a moment. Wave. Let's try. Sorry, I'm thinking about firmware while doing this, so my brain is in multiple places. Let's see. Ooh, that's the Arduino IDE opened with a client project, so it's a good thing that I did not have the desktop visible. All right, I'm going to change the. I have a couple of MQTT brokers on my network. There is the one that I actually care about, which in my home automation system runs on, and it uses encryption and all the good stuff and authentication. And there is the other one that is just like a general purpose broker that's got no authentication, and I just throw any random thing at it. Sorry, I'm having a look through this while I'm going to upload new firmware onto that in just a moment. Let's see, dev module, I want ESP8266, LOLN32, and I'm not showing you this because at the moment on my screen I've got all my Wi-Fi details. So, switching to D1 Mini profile. Come on. All right. Oh, yeah, Peter said, wasn't the reason this was designed so you could put the display on the live feed? How are you going to do that? That is a very good question, and that relates to the stuff that I've got on my laptop that I will hopefully get to in just a little tickety minute. What have I got here? Sorry, I'm also making changes to the thing to upload it. Which port? It's USB port 240 and upload. All right, compiling. Scott says you need a lab AP for testing and live streams. Yes, I do. Mike, yes, all the credentials, all we see is star, star, star. Yeah, I have Unify access points which support up to 4. You can run 4 different SSIDs on them, and at the moment all 4 are in use because I have a normal Wi-Fi network, I have a guest Wi-Fi network, I have an NOT network and an IoT network. So I can't add a 5th one, which is just for testing. But of course I can just run my own access points. I've got other access points. In fact, the one here. Oh, let's not go down that. You can tell that my brain is not on the job today. Still compiling. Come on, you can compile. Johnny says there are JavaScript libraries so you can subscribe to MQTT in the browser. Yes, nice. Now, let's see what we can do here. I'm going to go, I wonder how, can I do 1 Hertz? Yes, I can. So now we'll get some more variation. You can see the display is jumping around. Oh, I've got an offset on here as well. So let's change the offset to 0. Oh, that was weird. All right, 0 offset, so we'll go between 0 volts and 5 volts. It's currently running at 1 Hertz. I wonder if I can make it lower. I've got no idea what the minimum frequency is on this. Let's try going down to, yeah, let's do this. We'll make it 0.1 of a Hertz. Oh, it just went to 100 megahertz. Okay, it looks like it can't go below. Oh, hang on, no, I think 0.1. Yeah, so 0.001 megahertz. 1 microhertz? Okay. Let's just try. I'll make it 1 microhertz. Okay. I didn't know it had... Oh, that's millihertz. Okay, no, I thought it was going to megahertz, but it was going to millihertz. That's cool. All right, let's make it 1 millihertz. Now let's take it up a little bit. I'll make it 10 millihertz. So, no, not high enough to see much variation in the output. 10, let's go to 100 millihertz. What I should do is stop and think about about what this actually means. So a millihertz, yeah, it's 0.1 of a hertz. 100 millihertz is 0.1 of a hertz. So it should be varying. What I'm expecting to see is more variation here. See, this is sitting right around 2.5 volts, minus 2.5. That multimeter is getting confused. So what we should be seeing is a sweep pattern that goes, let's just change it to, let's make it a sine wave as well, rather than a square wave. Maybe we'll get some more interesting numbers coming out. Yeah, that, apart from those negative numbers, which is just weird, that is more like the sort of semi-randomness that I was expecting to see with a 100 millihertz sine wave from 0 to 5 volts. Not that it matters. The point is that we're getting numbers coming up on the multimeter, and that was what I cared about. Oh, this thing's finished compiling and uploading. Let's see what is happening on the serial monitor. And I'll switch you back to this other view in a moment. Where are we? Desktop. Desktop. There we go. Okay, so this is the serial monitor now coming off it, and you can see that we're getting actual numbers here. So we're getting data coming from the multimeter. And this 4 that you see appearing here, I have a feeling, is that when it goes negative? Oh, I know why it's going negative. And I bet, I bet you are all telling me this. It's because I set the offset to 0. Yeah. It'll be sweeping between negative and positive, but why? I just saw a negative 20 on there. That doesn't make any sense. And 20, unless it's the scale that's going strange, it might be like 20 millivolts. I think the auto ranging on the multimeter is maybe having a bit of a freak out. Plot twist, he's killed the meter. Maybe. G'day, Mako. Yeah, so where to from here? We have data coming from the multimeter. We are reporting it to the serial port. Now, I'm just going to switch this view again while I do something else on my computer. What I need is a computer set up just for live streaming that doesn't have any confidential stuff on it. Okay, so back to desktop. Okay, so we have a let's zoom this in to make it easier to read. Bring it down here. And what do we need to subscribe to? I'm just going to hit reset on here so that we get it startup messages and turn off auto scroll. So this is the topic that we want. So what do I do? Mosquito sub minus v minus h. That's the general purpose miscellaneous broker. And then I want that, that as the topic. And do we get anything? Yes. So we are getting the same data pushed to the MQTT broker. Now this is where we can start doing some decoding. Back to here. And it was actually a few weeks ago that I was looking at this, so I'm not sure what state it is in. Not feeling up to watching streams, yeah. Right now I'm not feeling up to doing streams. Come on, wake up. Either my laptop is frozen. Oh no, it was just taking a really long time to come out of sleep. So, this is going to be super uninteresting for just a moment, but I'm going to just see if I can find the packet decoder that I had on my laptop. It was where? I don't even know where I had it. Where did I put it? Maybe. I have a feeling that it was a module that like a Python module that I installed. Anyway, if this takes me more than a moment to find, I'm not going to screw around with it on the live stream while you're all sitting there. Or I should say, go and talk among yourselves. Grab a cup of coffee or something. Is it in the README? Oh no, maybe it's in resources. Yes, this is absolutely riveting, isn't it? No, I don't know where it is. UT. No. Anyway. I will find it and okay. Scott, I need to fix, so I got local DNS. Yeah. I don't know, it's never really bothered me. For some reason I prefer using IPs rather than host names, because whenever there is a problem with the network, it's always DNS. So if you eliminate DNS, you eliminate a whole lot of problems. I just like the certainty of of talking directly to an IP address. So Aaron asked the very good question, which is your plan to pass on the ESP and send via MQTT, or pass raw over MQTT and pass on your PC? And the answer is both. What I'm intending to do, so step one is what we've got right here. If we come into here, we've got in the somewhere, I'm resisting the urge to click on the config tab because that'll reveal everything. But down here, okay, so what we've got is there are two topics that are defined. There's the raw topic and the JSON topic. And at the moment, what's happening is that we are taking the data and where is it? We are just reading the raw data, building it up in this buffer. So we've got the GMQTT message buffer, and as the characters come in from the multimeter, we're just building it up and then reporting it to MQTT. So we're not doing any parsing at all on the D1 Mini right now. We are taking the raw information and passing it on. So what you are seeing in the serial console, and Aaron, I'm pretty sure you already know this. I'm just kind of summarizing it for people that have joined more recently. So at the moment, what you're seeing in the serial console over here and reported to MQTT over here is the raw packet. So that these characters are exactly what is coming back from the multimeter. Encoded in that is the value that the multimeter is reading and other information like what mode it's in, whether it's in volt mode, and one of the digits is the decimal point offset. So for example, you can say that you're in volt mode, and then you can use the offset to figure out whether what you're looking at is volts or millivolts or whatever. So contained in these characters is all the information that you need to extract the information about what mode the multimeter is in and what the current value is that it's reading. So there are a couple of things you can do. And as Aaron very astutely questioned, we can either simply pump these raw values, so these raw packets, off to MQTT, and then from the point of view of the interface, like this little device that we built, be done with it. You don't care about it anymore. You're just acting as a gateway. And then that has to be processed by some script elsewhere, something that is subscribed to MQTT or that is reading the data off the serial port. But alternatively, what we can do is add a packet decoder in here. So what we do is we build up the data by reading the characters coming from the multimeter until we've got a packet. And then, so here we've got the, no, that's not even being used right now. Everything in report to MQTT is currently being, is commented out. This is leftover stuff from when this firmware was originally done on the air quality sensor. And you can see here it's got the section where it is printing the buffer. So this is an example of forming some JSON to insert values. Anyway, my plan is to get back to using this to add a decoder in here. And what the decoder will do is look at the characters in the packet, figure out what mode the multimeter is in, extract the value that is being read, and including the position value for the decimal point. And then depending on what is being read, it will form up some, I think probably just JSON is the easiest. It'll form up some JSON and report it. So what we will get back is two sets of data. And of course, if anybody else wants to hack around on this firmware, go for it. These are not the only ways that this can be done. So what we'll get back is the raw data, which is exactly the packet as it is, and then also get back a JSON message, which can include the decoded version. So if you just wanted to watch the feed, you would see, oh, we're in volts range and this is the value, or we're in current range and this is the value. And I still don't really know how that JSON should be structured. I think my first impression is that there would probably be an attribute for the range and an attribute for the value. And those are really just the, like, it sounds very simple. There may be some complications to it, but I think that's probably all we need. So down here where we're reporting it, what have we got? PM, I mean, this is obviously for the air quality sensor. It's got particulate matter values and things. But what we would do is, it would be like UT61E, and then we would have range, and then we would have value, and, you know, get rid of that. And this would be GUT. I mean, these, I'm just making these variables up right now. They don't exist. UT61E range and UT61E value, get rid of that, and that, basically. So this is what it would be. We'd create a buffer with the range and the value in it and report it as an MQTT, as a JSON message. Just gonna hit save on that. So in the short term though, the thing is that decoding the packet is kind of annoying, and it's already been done by other people, not in like an Arduino or an ESP8266 type environment as far as I can see. Let's see, Python UT61E packet decoder using the power of Google. Somewhere oh, here we go. It's in my history. So this thing reads, let's see. All right, maybe we can do something with this. So what I did with this previously, where are we? Pip install UT61E. Let's see if this works. I've just opened it in another console. So what, all right, so backing up. What I found, I'm gonna, while this other thing is running, I'm gonna explain what this does based on my very dodgy memory from several weeks ago. And you all know that my memory is bad, so I'm probably going to be telling you totally the wrong thing. So, ooh, I think it's installed. Pip list UT61E. I may even just be able to demonstrate it rather than trying to explain it to you. Yeah. Okay. Sorry, I'm doing some off-screen typing for a moment while I just check what happened with this installation. UT61E. Pi USB. I have a feeling. Ooh. Pi. HID API. I can't remember which one of these. Pi USB. No, HID API. That's. My memory is coming back to me now. Okay, so I'm going to switch this over. This could all end up being a total major fail. So what we've got is, what I've just done was a pip install UT61E, and what it's done is installed this package, and it includes a couple of Python scripts. So there is the HID API script and the Pi USB script. Now, what I discovered, let's see if I can, Python 3, I'm trying to remember how I did this. I think what I did was subscribe to, right, let's try this. I'm just going to do that and then pipe that to that. Will this work? I don't know. The thing is that my Python installation on here is really screwed up. Permission denied. Okay, so is that going to do anything? Python HID API. Yeah, there was something I did to get this all working. Let's just have a look at this. I have a feeling that what I did originally was I changed this to explicitly be, all the Python people are going to be shouting at me. So user bin Python 3, I think. Which Python 3? User local bin Python 3. Is there a user bin Python 3? Come on, autocomplete. I don't know which one. Python, yes there is it, okay. Let's just try this. So we've got that, permission denied. Let's just use the big hammer and see what happens. Okay. All you can see was ... All right, command not found. UT61C, I don't know. Unexpected maker shouting at you. Okay. Yes, I know. All of the Python people are shouting at me. So where is Sion's? I'm looking back at. All right, so Kabletti said, so I was wondering for this UT61E readout tool that maybe generating a direct video stream with the readout in it that could be used as feed into OBS or something. Is that too hard? Yeah, so basically treating it like it's a webcam sort of thing. I don't think that's necessary because what we can do is make a little interface. It could be even a web page and just have a very small web browser window and then just capture that window into OBS. So I think we can do it in a simpler way than generating HDMI and then capturing the HDMI. Yeah. All right, now, look at Aaron's notes. His suggestion and code is a much better solution. Okay, cool. I guess that is in the Discord. All right, so I should go and have a look in Discord and be totally freaked out by user local bin and be totally freaked out by, oh, this may even be Python 2. Maybe that's what's going on here. Yeah, maybe. No. There was a what am I looking at? Okay, so I will go and have a look in Discord in just a moment, but first, while I'm trying to figure this out, using HID API provided by the operating system, or except it allows to read from the USB HID adapter cable. Yeah, when I did this a few weeks ago, what I found, the very brief summary, is that, oh, that's what I want. Yes, I've been trying to run the wrong thing. It's the, I want the ES51922 script, which is, yeah, there it is. Sorry. Yes, I knew that there was some little trick here that I discovered a few weeks ago. UT61E and I will get to Aaron's thing in just a moment. All right, we are actually getting somewhere here, I think. Permission denied. Come on, not found? Okay. Gone silent while I am frantically typing off screen. Python 3. Is it Python 3 or is it Python? Python 2.7. Python drives me nuts. Such a mess of versions and working spaces and Okay, Python 2.7, I think. Yes, okay, I've had some success. Sorry, I've been doing something off screen here. User bin Python, yeah, this module still requires Python 2.7. So, oh, come on. Which Python 2.7, user bin Python 2.7. Okay, let's try. Yes, this is not my happy place. Let's try that. Aha, yes, okay. We are making progress here again. All right, where am I? Back in this console. All right, so what I want is not that. I want that. And I think because my permissions are screwed up, I need that. Let's see if this all explodes. Come on, not found. So, if I do that, it's going to say permission denied. All right. But the setup on my laptop was different. No, anyway, a whole lot of messing around. Let's have a look at what Aaron is suggesting, because I'm sure Aaron is much smarter than me and has a much neater way of doing it. All right, going back. Aaron. Okay, having a look in DM. Oh, wow. I don't think I can drag. I'm not going to pull. No, actually, I'm definitely not going to pull this onto the screen where you can see it, because Aaron has it's got some personally identifiable information in the private chat. But this looks amazing. So what Aaron sent me is a message saying that he started on a desktop app for the UT61E Wi-Fi to MQTT board, and I'm gonna, let's see, I'm gonna get this out. I want to show you this screenshot because this looks fantastic. Let's see if I can get this screenshot out somewhere that I can show it to you without revealing all of the private chat that Aaron has sent me. Look at this. So cool. It's got the Unity logo in it. Looks great. So, Aaron, I'm impressed. What was this done in? Yeah, okay, Aaron, I will send you one of these. Do you have a multimeter? Do you have the UT61E multimeter? I can't remember. I think you might have mentioned at some point. Yeah, I'm scrolling back through the private chat. I can't see it. All right, back into the live stream chat. Ooh, Aaron sent me also a Dropbox link. If I click that, I'm just wondering if it's going to open somewhere. No, it opens off screen, which means I get to see it before. Yep, it's the same screenshot as I've just grabbed out of the private chat. That looks so cool, Aaron. All right. Now, Aaron says, nope, but I'm willing to buy one. You'd buy a multimeter just for this project? Now, I do actually like the UT61E multimeters. They are, they're still, after all these years, I think pretty much in the sweet spot of being a decent multimeter at a reasonable price. In fact, I bought one for Chris for his birthday only a couple of months ago. So I still think they're a good value. So Aaron, if you were going to buy a multimeter anyway, then go for it. UT61E is a good one to buy. But I don't like the idea of you going out and spending money and buying a multimeter just so that you can work on this project. That's it seems like it's an unnecessary expense. So if maybe we can work out some way that I can do the testing for you or whatever. But in any case, I am very happy to send you one of these. I've already got your postal address, so I can send one to you. And then we can have this awesome looking multimeter interface. Aaron says it will render real-time QTT messages to a given topic, just waiting to learn approach to see if I need to work on parsing application side or if the device will parse it. Okay, now I want this to be able to report pre-decoded messages. So right now, yes, you would have to do the decoding, but the decoding, I don't want you to have to worry about that, because what I really want is for this to be able to push the data to a broker and then have different UIs. You might have, for example, you might want to pull the data into a database, like a time series database, and log it over time. And that way what you could do is use a multimeter for things like long-term testing, or for reading, I don't know, reading voltages off batteries over time or something. Anyway, there are all sorts of situations where you might want to use an interface like this to read data and store it or display it in different ways. You might want to stick it into a text file and store it like as a log file with timestamps, all sorts of things you might want to do. So I don't want to put the burden of decoding the packets onto whatever is going to be using the data. That seems like taking a problem that should be solved in one place and making it be solved in many places. So yeah, you could display it in Home Assistant. Yeah. Otherwise, we're going to end up with duplication. Like you'll end up with a packet decoding routine written in Python, and someone else will do one in C, and then there'll be a version in pretty much everything. And I would like to have it just output the data already parsed. Now, what I was working on showing you, and because of my messed up Python setup on my computer. All right, so where I was going with all of this, let's try, where do I have it? Now, on my laptop, this works. Just get it so that it's not wrapped. So what happens is, I've got some permissions thing. I don't think I'm going to dig into this right now. So on the laptop, if I do, which one is it? I think it was with Python. Yeah, basically that. In fact, let's just see if I can get this going on the laptop. Mosquito. No, maybe not. Why? What is going on with my laptop? Mosquito is not. Which mosquito? Sub. All right. My whole computing environment is a total shambles right now. Anyway, what this does, this utility, the ES51922.py, and what it does is act as a decoder. In fact, let's have a look at that. And you can feed it a raw packet from a UT61 multimeter, and it tells you all sorts of useful things. It's probably not a whole lot of point reading through all of this, but yeah, so range voltage, it's reading the, it sets the different ranges based on decimal point position, all of that sort of thing. So it's using these bit masks to set the range. So it's got all those definitions at the front, capacitance, etc., continuity, discovers all of those things, and different functions to deal with the different modes, lots of definitions. So all of this stuff is being done in, and it goes on and on and on. Here we go. So there it displays some results. And down here is where it does the actual parsing, I think. Parser add argument, blah, blah, blah. And it outputs values to a CSV file. Oh, you can also have no file. By default, what it does is write the outputs to a CSV file, and it displays the values in a human readable format as well. So, where are we? Help, output file, verbose, M mode, CSV or readable. Output mode default is CSV. Yeah, anyway. If my computer wasn't a mess, this would work. And so what it does is it just accepts the packet on standard in. So by taking the output from the subscription and then just sending it to this library, if the permissions on that were working okay. Hang on. I know this is going to be super ugly. Oh, I hate to do this. Let's just see if this makes any difference. Permission denied. No, there's something else going on. No. I'm not going to do any more live debugging. It's kind of annoying. Yeah. Oh, Scott says, I'm looking at an Amazon listing just under $100. I can't remember how much I paid. I think Amazon would be probably more convenient for you because I think it ships quickly. If you're not in a huge hurry, you can order it from the Unitrends official store. And for anybody who is wanting to have a look at this, to mess around with this themselves, and is actually wanting to buy a multimeter, where is it? So on the gear page, I've got links to this. Do I have a link to the multimeter? Multimeter, this one. Okay, is it a link? Yeah, so this is, full disclosure, this is an affiliate link. So if you come along to superhouse.tv/gear and then come down to Multimeter and click on the Unity UT61E, that's an affiliate link that will take you to AliExpress, and it's the Unity official store. So this is where, this is actually the manufacturer of the multimeter, selling them on AliExpress. $59.60. What's the shipping? Is there shipping? It's free shipping. Okay. So $60-ish US with free shipping to Australia. It'll take a little bit longer than if you buy it through Amazon, because I think the Amazon seller will probably have local or semi-local stock. Yeah. So as Aaron said, if it outputs in the feed, we can visualize anything. The desktop app could potentially do hold, graphing, storing, etc. Yeah, that's really cool. I like that. Aaron, I'm really impressed with the with how you've done that. Scott Miller, 75.85 Canadians. Oh. So Aaron, your last express took 16 weeks to arrive. That's not good. I wonder if that, oh, so Sion asked if I could post this link. All right, this is the gear page. I found that AliExpress recently has been really quick again. We had that really bad period where the world's logistics infrastructure seemed to totally just fall over and become useless for a year, probably nearly a year, but it seems to be back and mostly working. I've been, hang on, I'm going to drag this off screen again, just while I open my Google Docs folder, and I'm going to check. All right, I'm going to reveal some of my AliExpress purchase history, because I track everything that I order, when I ordered it, when it arrived, and calculate shipping times and all that sort of thing. But I just want to open this off screen before I potentially reveal things that I shouldn't. Now, okay. Oh, are there any things here that I have received? Sorry, still loading the Google Doc. Loading, loading, loading. All right. I think it's okay for me to show you this. I hope I'm not going to reveal anything that I shouldn't. One thing I don't know is whether the URL for the spreadsheet in itself is confidential. I don't know. I think this is, I don't think you can access it. Even if you see the URL for this, you won't be able to do anything much. So this is my spreadsheet of Superhouse parts orders. So what I've got is what I ordered, how many, the price, which is mostly in US dollars, what the total was for that particular order, how much tax was included, the date it was ordered, the date it arrived, and then a calculation column for how many days it took to arrive, and just a thing of whether it has arrived, and notes and the URL, so that if I want to, I can just reorder. So I can look back at what I've ordered in the past and then click on the link and go back to the original seller. So you can see there are, and this is just the Freetronics one. I've also got another spreadsheet for, oh sorry, this is just the Superhouse one. I've got another spreadsheet the same for Freetronics purchases, but that is considerably longer. It's many hundreds of rows. So if we look back at some recent purchases, and this is AliExpress, screw terminals, 100 pack of screw terminals took 14 days. These were really impressively fast. I ordered a 10 pack of Xiaomi Zigbee environmental sensors and a 4 pack of door sensors, and they arrived in 7 days. And this was ordering off AliExpress. So, and I don't think I didn't pay for a DHL or anything. That was just like e-packet shipping. That to get something in on e-packet from China to Australia in 7 days from the time that it was ordered, that is pretty damn fast. And likewise here. So this was also AliExpress, and I'm pretty sure this was not local stock. I got 50 DB37 PCB mount connectors, 50 plugs, 50 sockets, and they arrived in 9 days. And so you can look back through my recent history here. There is nothing here which is really shockingly long. These arrived in 15 days, 9 days. Oh, this was transceiver modules. So I got 20 modules, 433 megahertz transceiver modules, shipped from China, as far as I know, just on e-packet, 9 days to arrive. So scrolling back through my history here, it's typically 2 weeks. I mean, there are some outliers. Look at this. This was a ferrule crimping tool set. That took 34 days. I ordered 50 Vroom 32 modules. That took 31 days. But most of these in recent times, so this is through April, May, June, and then into the start of July, and you can see the most recent ones haven't actually arrived yet. Oh, these ones are taking a while. I ordered 150 RJ45 sockets, the 4-way sockets, and that was 2 weeks ago. So that's not taking a long time. That's still only 14 days ago. No, 17, 18 days ago. But still, that's quite reasonable. If they arrive this week, that's a pretty respectable time. Yeah, so at least to Australia, ordering stuff from AliExpress is not being ridiculously slow. So if we go back a little bit, you can see some stuff just never arrived. Yeah, even back here, when was this? June 2019. So the period when things were really bad was through 2020, basically. Let's see, July 2020. This took, oh, these were LCDs, so I ordered a couple of LCDs and they took 42 days to arrive. RJ45 Ethernet extensions took 23 days. Even that's not horrible. What have we got? USB-C cables, anti-static bags. These took a month and a half. Ooh, look at this. Ziploc bags took nearly 2 months to arrive. When was that? January 2021. Yeah, but the most recent stuff, if you ignore the stuff that hasn't arrived yet, yeah, this one's getting a little bit long. That's going to be a long delivery time. But if you look down here, most of that is pretty respectable transit times. Yes. Now, where am I? What am I? I'm just someone trying to get by in the world. Now, where to go with this? Oh yeah, so, yeah, 56 days on those Ziploc bags. Yes, what are we doing? I don't know. The signal generator seems to have gone to sleep. At least its screen has gone to sleep, but it's still outputting stuff. All right, I need to write a little to-do list for myself. And no, nobody suggest a Trello board, please. Trello breaks my brain. Multiple times I've had people that I've been working with on projects set up Trello boards, and things like Kanban is okay, but for some reason, I don't know why, I think it's the Trello software itself, the way the interface works. I just can't, it's like I have a selective blindness for it or something. And yes, I know it's just like post-it notes and moving along between columns and things, but it's still, for some reason, Trello just really annoys me. Okay, so what I need to do, my to-do list. I'm going to end a live stream with some homework to do. So post Aaron the UT61E board. That is item number 1 on my to-do list. Item number 2 is get decoder library working. Okay, so that what I'm going to do is mess around with the environment on my computer and make, wherever it is, my terminal's gone now. Where's the terminal? And make this work, because at the very least what this allows is to push the raw data to MQTT, and then we can decode the packets and we can see what state it's in. And that can be very useful as a way of then validating whatever other implementation that is done. So where I want to go with this is I want to have 2 MQTT subscriptions running side by side, and one of them is going to be to the raw data and then displaying the decoded version and then using this to decode it, and the other one is going to be to the JSON topic, which will be the data that is decoded on the D1 Mini. And in theory, those 2 things should give the same values. So what we should see is a series of bits of readings coming out of the multimeter from those 2 different sources, one via this Python library, the other one being decoded on the multimeter, and the values should match. And then switching between different ranges and things, they should both show the same thing. So that's how I'm planning to validate the, so this is assuming that the Python library is working properly. But this is how I'm planning to validate that the thing is working. What was the 4-channel scope on the planet? Okay. Sion has my phone number. Is my phone on silent? I don't even know where my phone is right now. Where? I put it down somewhere. So, Mako says, Sion needs my phone number to get my attention. All right. Okay, I'm going to go digging back through. What has Sion been shouting at the computer and trying to tell me? Oh, Sion, you just ordered one of those multimeters. Cool. Right, Sion. Yeah, oh, so Sion says you've been getting stuff much faster as well. So Aaron said, do I have a reference or docs on how to decode all the data? What is the extent of what's outputted? Are you wanting to digitally replicate the UT61E visible screen data via MQTT? The short answer on those is yes, yes, and yes. There is a reference. There is a doc from Peter Lawler is using alternative channels to ping me. Okay. Let's see what Peter is pinging me with via back channels. Yeah. All right. Oh, okay. I'd just like to post a link to the Superhouse product page for the Wi-Fi adapter. All right. Let's find that. Too many things open. I think this will be it. Superhouse.tv UT61E Wi-Fi. Just before I hit enter, I'm going to test whether that works. It's a this is the shortened version of the link, which then redirects to the actual thing. Is it? Does it work? Yes, it does. There you go. Oh, wow. Hang on. It says 5 in stock. Someone's just ordered one. Okay, now, what has been... Peter's just sent me a very funny animated GIF of a squirrel. Yes. All right, so Aaron, I will post you one of those modules. Oh yeah, that'll delay the start of the project. 15th of August, July. That is a long time. I wonder if they are being super pessimistic about their shipping estimates, and it'll actually get there faster. Don't know. Oh, there it says 5 in stock. There it says 6 in stock. All right, let's get out of that. I don't know what I'm doing. I need more caffeine. I definitely need more caffeine. What I need to do is do Sion's thing of bringing the coffee onto the live stream with me. 4 left. Ooh. Maybe I'd better start ordering ordering more PCBs with the version 1.1. It'll be fine. All right, so for the people that have ordered it, I assume that the 2 people that have ordered this are in the chat right now. And do you want me to just ship it to you as is? Or do you want to wait a little bit and get the clear heat shrink around it? Because they're, even though I've made them available on the online store, yes, they still need the heat shrink. Ooh, looking for the members discount code. Ah, good point. Cable tie, Cabletti, discount code. I was going to mention this. So it is now the 4th of July here in Australia, which means that we are now into the next quarter, which means there is a new discount code, and I've only been 4 days late. So if you are a Patreon supporter or a GitHub sponsor, just a little bit before the live stream, I send out an update with the new discount code in it. And you'll also... So check your email for that. And that same discount code will get you access to the latest post on the Superhouse site, which is the still work in progress draft of the 2-year conversion video part 3. And so at the moment it's listed as a, hang on, let's go there. And then everybody else can kind of see this as well. So the latest post on the Superhouse site is this one. Tasmoda conversion with a direct serial connection. I'm just going to move this off the screen and put in a password. I'm just putting in the current supporter discount code, which also works to get access to this post, which is not finished yet, and it's got this part in it, insert video here. So this is where the video is going to end up going in, and I'm still writing this page, but it's getting there. So I've got an explanation of bootloader mode, what you need to control, what connections you need to make, and different 2-year modules, and I've got the 3 most common 2-year the 3 most common 2-year modules with Espressif chips on them are all laid out here with the pinouts and what you need to do serial reflashing. Anyway, that's a work in progress, and I was hoping to have that little video up actually a little while ago, but the last few weeks things have been going on, so I haven't yet. It will be soon. All right. Yeah, Sion says, thanks for your order email went right into my spam folder. Yeah, I have a very poor delivery rate for the automatic notifications that come off both the Freetronics and the Superhouse sites. I think what I need to do is switch to using a different delivery method. I was running an SMTP server directly previously, and then on one of them I switched over to using Gmail's outgoing mail servers, so it authenticates against Gmail and then sends them, and that seems to get better delivery. But I very frequently get emails from customers saying, I ordered this a week ago and what's going on? Why haven't you shipped it yet? And in fact, they were sent an email when it was packed and then another email when it was shipped, and both of the emails ended up in their spam folder. So they think I've been ignoring them and their order has been shipped. They just didn't see all the notifications. All right, so Aaron says, happy as it comes. Now, who was it? I have a feeling that it was James who had offered to design a 3D printed enclosure for this. And whoever it is, if whoever it is speaks up, I will post it. Or maybe it was Ben. I can't remember. Yeah, I know you need SPF records set up. Yeah, I've done SPF. So SPF is Sender Protection Framework. Yes, I've done all of that. I spent many, many years running many servers. And I don't want to deal with that stuff again. That's why I don't want to deal with DNS again. Oh, interesting. So Christopher McAvaney said, in that blog post, are you covering the power requirements for flashing via serial? I hit lots of issues with flashing until I used a dedicated power supply independent from the USB to serial converter. That's a really good point to raise. I have not had that issue because the two devices that I use for flashing both have onboard voltage regulators that'll deliver up to 600 milliamps. So I use the the APK2112, I think. I can't remember. Anyway, whatever it's the tiny little SOC23 style voltage regulator, the very common one that many people use these days. And so things like the ESP flasher, this thing can deliver 600 milliamps, which is plenty basically. So it's got the voltage regulator on there, and the other device I use typically is this one. So this is the USB to serial converter. It's got a different voltage regulator on it, but it's still rated for plenty of milliamps. In fact, that's the voltage regulator there. So this one runs in 3.3 volt mode. It does the I/O at 3.3 volts and it supplies 3.3 volts. But a lot of the really cheap USB to serial converters have, well, most of them are only 5 volts. And in fact, one of the issues is that a lot of USB to serial converters that say they are 3 volts or 3.3 volts actually supply 5 volts on the power rail, and their data lines run at 3.3 volts. So, which is not much good when you're trying to power a target device, which is meant to run at 3.3 volts. So, you've raised a very good point. Yeah, I should probably mention, I'm going to stick that on my to-do list. I am going to add a to-do item, which is talk about power requirements for flashing. I'm going to add that into part 3, and we can call it the Christopher McAvaney section of the video. Yeah, that's a particular problem. I know of the problem, but yeah, I don't normally think about it because the particular devices that I use can supply enough current. So yeah, I will mention that. I'll talk about that because that's something that can really trip people up. If you get a USB to serial converter, you connect it to your target device, you try to communicate with it, and it's not working, and you don't know why. That can be really, really frustrating. So, yeah, cool. Good point, Christopher. Thank you. Scott says, I recently added a switch to my standard programmer to let it flash devices with their own power supply. Yes. So, that is also a good solution. I didn't make it switchable on this, but you could. That, yeah. On the... This is actually hacked together for that very reason. So this USB to serial converter, which you can't see very well because it's very small, and we're zoomed out, it's got a little switch here to switch between 3.3 volt and 5 volt mode. It's got the FTDI type header on here, and it supplies power out wherever it is, one of those pins. But it always supplies power. You can switch the voltage, but you can't turn it on and off, which means you can't isolate it and let the device run off its own power supply. So this specific one that I've got here has been hacked. What I did was cut the connector, put a little 2-pin header on there, and then I've got a jumper. So if I pull that jumper off, it isolates power on the FTDI header so that I can have the target device run off its own power. And but it's not a feature of the board itself. So having a switch on it to just make it easily selectable, that's a cool idea, Scott. I like that. It's on this board. It's got a jumper. So this is slightly different, but this is the USB ASP ICSP programmer for AVR boards. And this has 2 jumpers on it. One is for the slow clock mode and the other is for power. So with this, with ICSP programmers, you often have a target board that is already being powered some other way and you just want to talk to it via its ICSP header. So with this, it's got a jumper on it. It's actually designed into the product. You just pull that off and it isolates power. You have a common ground, but you're no longer supplying power to the target. Anyway, squirrel chasing. Peter, you ordered $1,500 worth of stuff. Where is it? AP2112K. Thank you, Graham, for the part number. That's the voltage regulator. Yes, it's in the mail, Peter. It'll be there shortly. Just keep waiting. Keep waiting. It'll get there. But first, you need to send me $1,500. Christopher said, are those ESP flasher devices available on the Freetronics website? Not on the Freetronics. It's on the Superhouse site. And superhouse.tv ESP flasher, I think that's the URL. I've just dropped it in here. Kapleti says only 3 UT61E Multimeter Wi-Fi interfaces left in stock. Oh, I'd better fire up the sweatshop and assemble some more. 50% of stock sold in the first hour and a half. All right. Any progress on the LSC? That is, you know how warped my sense of time is? I actually thought that I would talk about the multimeter interface for like the first 20 minutes of this live stream, and then I'd be talking about the LSC. So let's bail on little squirrel. Oh, you can't even see it. Where are we? Desktop. There. Let's bail on our little squirrel buddy and talk about the light switch controller just for a moment in what time we have left together. I've got to clear some space. What do I want? That. I'll turn that off. Get this out of the way. I need to make myself some room here. Get that. Hopefully not cause any short circuits while I'm randomly moving stuff around. Oh, and this lead fell out and just reminded me, on my most recent LCSC order, I included some sockets for making a multimeter. I really do not want to chase that squirrel right now, but since people have been talking about it, I have been super tempted to design a multimeter and put an ESP32 in it. So I use an ESP32 as the main board. Put a big touch screen on it, like a, you know, somewhere in the 3-inch region touch screen, and then we could have our own smart multimeter, which could do data logging, and it could read. It could sample faster than the UT61E. All right, making some space, and I've got to grab, just sliding out of your field of view here, over to grab the light switch controller boards. Woo. And overhead, there. Now, so that's my, you've seen this many times, that's the prototype still hanging around. The test switch that I use just for checking things are working. I've got the 8-port version and the 16-port version there assembled. Shove that over there. I'm going to grab that again in a moment because I'm going to talk about restructuring the layout of all of this and the universal rack controller project. All right, these work. That's it. On to the next thing. Next subject. No, not really. Okay, let's look at these in a little bit more detail. So these are the interface boards that the light switches plug into, and the idea is you can use these to build your own light switch controllers. This is the super brief summary for people that have come late to the party. We've got an 8-port version, a 16-port version, and I have not assembled one, but we also have a 24-port version. And because, as we've seen in previous live streams, the design for all of these came from the same thing. So this was designed first, and then all I did was take a hacksaw to the design and cut the end off it and move this connector along to make this one. And then I did the same thing. I took a hacksaw to the design in Eagle, a virtual hacksaw, cut it off, moved this connector along, and made that one. So all three of these are actually designed from the same source schematic that simply had pieces deleted to make the shorter version. And I've tested this, I have not yet assembled this, but my confidence is fairly high that it is going to work when I assemble some. And I've gone through and tested every input on every port, and they all work. And with the new firmware that does multi-press detection and long press detection, all of that sort of thing, it is working brilliantly. So we at last have ourselves the basis of an updated version. I should have done it this way. Of an updated version of the light switch controller. Now, there are other parts to the thing. There needs to be the controller that talks to all of these via I2C, and the display and anything else that needs to go on the front panel. So let's talk about the universal rack controller just briefly. Now, so when I did this layout specifically because I was trying to copy the layout of a Cobalt rack. Little 1U servers, and I used to use a few of them in my software business, like in my internet business back in, when would it have been? It was like around 2001-ish, give or take. And I really like those little things. They were kind of flawed in some ways, but they had style. They were cool. So what I did was I just copied the menu system, like the way they had a little 2-line character LCD. This is an OLED, and I just copied this so it had up, down, left, right navigation buttons, and then it was select and enter, I think were the 2 buttons here. So with those 6 buttons, you could navigate around menus and set the IP address and configure it basically. So using the menu that is shown on the screen. So when I did this, I specifically set out to replicate the way the Cobalt rack worked. And that's why the layout ended up like this. So we've got the inputs in the middle here, looking a bit like an Ethernet switch, even though it's not. We've got Ethernet coming in on the side, which is passed through in this particular version, going to whatever the board is back here. And then that board could be an Arduino, could be a Raspberry Pi, could be like an ESP32 base board. That then talks via I2C back to the interface board, although right now you can see this isn't even plugged in. Yeah, it talks back to the interface board. And in fact, the reason this isn't plugged in, I think, is because I was using it for testing this. So if I just plug this into here, I could probably get this working. What do I need? I need an Ethernet cable. I've got an injector. All right, Ethernet cable. So I can plug Ethernet into there. I've got a PoE injector just up here. It's just slightly out of camera view, so you can't quite see it. And what I want to do, I want to shove power into that injector. Okay, I'm going to shove power into the injector. This should wake up the board. Do I have power? No. Oh, I know why not. It's because I grabbed the wrong lead. I want this one. Let's send 12 volts into it. And now you can see that this has started up. It's connected to Ethernet. And it'll be ready to read inputs from this. So if I take my test light switch and plug it in here, I can't even remember what broker or anything this is configured for at the moment, so I'm going to slide back over to my computer and have a quick look. I'm just going to, before I reveal this, because this one might be publishing to my real MQTT broker. Let's just see if I get anything coming up there. Am I getting button presses? No, it must be on my real MQTT broker. So, please indulge me for just a moment while I put my username and password in here. It's a moment where I thought maybe I'm sharing my screen and I'm not. Let's see if this works. It does. So I'm just gonna, sorry, I'm doing stuff while not talking. All right. Just gotta make sure that the password and everything is scrolled up off the screen. Yes, it worked. Okay. Now I can go back to desktop view. All right, so what we've got here is a subscription to the topic well, basically what I've had to do is I've done a wildcard subscription and then I passed it through grep. So I'm looking for the ID of this controller. So now if I press these buttons, you'll see button events. So buttons 9, 10, 11 and 12 are on here. And you can see the event type is double or triple or single. So which way is it? That way. This should be button, that is button 9, a single. Now I'll double press it. Oh, penta. Quad. Double. All right, so there seems to be a little bit of unreliability with the timing. That's all right as a triple. I just did a double. What I'm doing now is double presses. 2 presses, it says it's quad. 2 presses, it's penta. 2 presses, triple, quad. Maybe because I'm not allowing enough of a gap between them, so wait a little while. No, it's still saying penta. Okay. But in any case, you can see that it's detecting the different. I'm just going to try a long press. So press and hold, let go. Press and hold. Yeah. And I think there's I don't even know what different types it detects. I thought there was a long press event. But anyway, it's doing different things. Needs a bit of debouncing. Yes. All right. Yes, I did kill off the internet for all of Australia with a test. So, what you are seeing is switch events being reported through this board right here that you can just see barely in the distance on the corner of the screen. This is the 16-port version of the light switch controller, and I've got a 4-port light switch plugged into it, and it is publishing to MQTT, and it's working. Yes, so where were we? Light switch controller. All right, that's right. I was talking about the universal rack controller. So there's there is, where do I go with this? Time is just about up, but I do want to mention this. All right, back to the overhead view. Now, so what you've seen is this is working in terms of detecting button presses, etc. So let's just get out of that. I'll pull the plug on this and mention this universal rack controller concept. So as I said, this was originally inspired by the Cobalt rack. And what I wanted to do, the whole plan for this was to have the metalwork and the control panel and the display. So like buttons and when I say control panel, I mean the display and the buttons as a board like this with some other device in the back here, and then the inputs from the light switches, but this could all be replaced. The general idea with this was that it was kind of a framework for making rack mount home automation devices and using I2C for internal communication, so that this could be replaced by something different. It doesn't have to be a light switch controller. And then there is, hang on. Yes, Peter is bringing up lunch. Of course. You know, I feel like I've been making no sense whatsoever today. You know, sometimes it feels like I'm just talking and there are words coming out. There is no continuity of what I'm talking about or what I'm thinking or what I'm trying to explain. I'm just jumping around. I'm just exiting out of a couple of things in the background here. That's it. Okay, now, So I'm just going to bring up another site, but I'm doing this off off screen again. What I'm just trying to do is find something to show you, but I may not be able to find it without a whole lot of messing around. No. Okay, so the idea with this is, I don't know, I think I will. Sorry, I'm going way back in history here. Yes, I'm doing stuff off screen. I apologize, but I'm just trying to get to something before that. Yeah, kind of makes sense, so I can do this before I wrap it up. No, maybe not. No, I'm not going to find it. Okay, before I go, what I should do is see. Yes, we all have those moments. I think it's because Peter is right, and I need to go and get lunch. So Christopher said, can I put one of those racks online so we can submit firmware fixes to upload and then you can press buttons to test? Ah, that's an interesting idea, like an online test harness. What would be really cool would be if I put a web interface in front of it that did virtual button pressing as well. Now the firmware for it all, if any of you want to mess around with it, is, sorry, I have totally lost the plot here. All right, so the place to start is here. This is the light switch controller repo, but the firmware that is in there is not the most up to date because there has been more development by Ben and others. So the place, I'm going to bring this over and switch to desktop again. So this is the repo for the light switch controller project, and in this is the other design files for the 3 different versions of the board, and there is also firmware, including an out-of-date version of the USM firmware. And where are we? Forks. So if we go and have a look at some of the boys. So if I went to the wrong thing, this one's what I want, LSC. So Ben's repo, so the fork of my repo is 7 commits ahead and it's got some more stuff in it. So what I need to do is pull the changes into it. But if you go to my copy of the repo as a starting point, or you can go straight to here. In fact, I'll drop this URL in as well. Ben's is pretty much always ahead of mine because he's making ongoing changes to the code. So what I'm running on mine right now, I'm pretty sure is out of date. It's I need to merge his changes into my copy of the repo. Yeah, so Aaron said, for the LSC logic board, are you going to design a new board like CM4 based or Pi or ESP hat? Okay, now that gets us to the whole concept here. And I'm going to come back to overhead and rethinking how this all fits together. What you see right now came about by directly copying the front panel layout of a Cobalt rack. And that's not necessarily the best way to do it. And so what happens is that, so we've got the LAN port over on the left. The way I wanted it was that if you walk up to it, you can access the control panel here, and for, yes, this is kind of being right-handed biased, I'm sorry. If you're using your right hand to use the menus, then the menus are visible on the display right here. And then data connection comes in from the left, and then all of the I/O is in the middle. But what that means is that the control panel over here and the data connection over here are separated. And that's not necessarily good. So what I was thinking of doing was combining them and making a version. Right now, this version has a direct pass-through. This RJ45 socket just passes through to this one, and it doesn't do anything else. There is no PoE extraction, there's nothing in here. This is just a direct connection between these two sockets, and that is purely so that there is a nice mechanical way to mount a socket in the front panel and then plug in whatever device you want in the back here. And my original idea was that you could mount a Raspberry Pi in here, or an Arduino, or whatever device. You could put a Nano ITX motherboard in here if you wanted to, and then just plug an Ethernet cable into it to make this connection. And then have another version of this that, instead of having the pass-through, it would have something like an ESP32 just directly on here. And in fact, I've got a partial board layout for that. But all of that has been scrapped because with this new version, what it does is it has the sockets. Basically, it forms this part of the board. It doesn't have any of this pass-through part, and that will end up being separate. My original idea had been to make a single PCB that did everything, but now I think it makes more sense to make it more modular. So what I want to do is I want to take this part of it, move it over to this side, so the display will be on the left instead of on the right. I'm probably going to get rid of all of these buttons as well, because I'm not even sure that it makes sense to have physical menu buttons on a device like this anymore. I think what it would make more sense to do is have, over on the left, we're going to have Ethernet, USB, and a display. And the USB can be used for either for configuration, or it could be used for loading new firmware. So what we'll end up with is, on the left-hand side here, we will have this and this combined into a single board, and then the right part of it will be where the I/O goes. So that's the general idea. But it doesn't change any of this. This works just fine. These can go there, or they can go across here. And then I'm going to get updated metalwork done. So all of this metalwork was designed in Fusion 360 and then laser cut and folded at a place not far from me, just 10 minutes down the road. So I can get them to make a new version with the updated metalwork. All right, I really need to follow Peter's suggestion and get myself some lunch. All right. Stephen says, doesn't it make more sense to move the input LAN port to the right with the display? Maybe. And Graham suggested it might be worth having one button just for a quick reset button. Yeah, I'm definitely open to suggestions on all of this. But this is where the universal rack controller concept comes into it. So the idea is, and this has been discussed before quite a few times, the idea is this functional part, the thing that makes this a light switch controller, nothing should depend on that. That could be replaced. So things like the user interface and Ethernet and the microcontroller and whatever else you want in there, that could all stay the same, and then you just replace whatever this board is, and instead of it being a light switch controller, it could be an interface for security sensors, or it could be, I don't know, an audio switching matrix, or whatever you feel like making. It could be interfaces for RS485 or CAN bus, or I don't know. But the whole point is that the things that are common to all of these projects, you should not have to do again. You shouldn't have to do metalwork again. You shouldn't have to do the Ethernet interface again. You shouldn't have to do power over Ethernet. You shouldn't have to do the display. All of those things can be just a standard empty shell of a project, waiting for whatever functional board you want to add into it to do the specific things that you want to do. So it'll be like a template for making rack mount projects with all of the common standard stuff: communications, power, user interface, metalwork, those all done for you, apart from possibly any custom holes that you might want to make for whatever your I/O happens to be. And then all you have to do is put in the portion of it that is specific to the project you want to build. The rest of it is done. Yeah. Alrighty. Needs a paperclip hole for a reset. For a reset button. Yeah. Saves you reaching around the back. Oh yeah, and a power switch. So that's another thing that might be worth putting on the front. I was thinking of maybe having either a latching illuminated button, which could be kind of cool, or an illuminated rocker switch. But then this is the thing where I end up in decision paralysis, because there are so many different ways I could do this. In many ways it makes sense to bring the power in from the back. So with the next version of this case, what I'm intending to do is make it not just a tray. I'm intending to make it like a fully enclosed case with a lid that you can screw on. So it'll have a back on it. And what you could do is have a socket on the back and bring power in that way. Because in a lot of rack situations, what you want to do is have power coming in here and then other connections from the front. Maybe that makes more sense. I don't know. Maybe we could put power connections on both the front and the back and just link the sockets in parallel so you can use either. Anyway, let's talk about it. Yeah, but where I'm kind of being inspired by at the moment is Unify Ethernet Switch Series 2 is kind of like this. Oh, I think I'm about to get, the live stream is about to get a surprise visitor. This is cool. Hang on, I'm going to switch to the main camera because you will want to see the surprise visitor who is coming in.
We brought you lunch.
Oh, you brought me lunch. Oh, look. Come on in closer. So Andy has turned up with lunch for me and Astra. Hello, Astra. Astra's only just in the field of view. Yeah. Need to come across a little bit more.
Yeah, I didn't want to break up the Wi-Fi, so I'll go and do some hacking over here whilst you're finishing up.
Oh, hello. Oh. No, this is not lunch for me. I think it's lunch for Astra.
The A10.
Oh. Yes, the A10. Okay, so perfect timing. Aaron says, "Hey Andy." And Astra says, "Hello." Hello, live stream. So I'm just going to switch to my desktop for just a moment because I wanted to show you what I've been thinking about in terms of this this layout. So where are we? The Series 2 switch. Which one? That one? No, that's not it. Oh yeah, that is it. So this particular UniFi rack mount switch has the display on the left. It's got Ethernet ports on the right, and then it's got some SFP sockets there. But this is the way they've laid it out. So what they've got is a little touch screen. It's actually a square touch screen that goes on the... There's a... Let's see if I can pull this image up. And this has a very clean look. So power for this comes in from the back, and they've got this touchscreen that you can use. You can do things like display a QR code on it and then do augmented reality stuff. It's all very fancy. But I think we need a little bit more than that. A screen is useful, but and you can see they've got a power socket on the back, but that takes mains power in. It's not just like a 12 volt in or whatever. Anyway, these are the sorts of things I've been looking at to try to come up with inspiration for how to set up the front panel for this, this universal rack controller project that can then be built into whatever it is you want to build. So, it is definitely lunchtime, and I've got a dog to pat. So I'm gonna go. So, thanks for coming along to a very random live stream today. It's felt very random anyway. And I'm gonna sign off, grab myself something to eat and drink, and say hi to Andy and Astra, and I will talk to you all really soon. Now, because I don't have my scene switcher set, I've got to manually end this live stream. But anyway, thank you very much for coming along. Sion, you just got back. Just got back from where? Where did you go? You should have been in the live stream the whole time. Not really. All right, Sion, say hello to Astra. Ah! You probably weren't here when Astra came in the room. Oh, hello. Yes, I love you too. So, I'm going to end the live stream and go and play with Astra and talk to Andy. Bye, everybody.